Hi everyone, I have another video here on 1D kinematics, specifically in the x direction. So the problem states, a car speeding at 150 kilometers an hour passes a still police car which immediately takes off with an acceleration of 5.6 meters per second squared. The speeder stays at constant speed. How long does it take the police car to overtake the speeder? What is the police car's speed at that moment? Now, if we look at what I highlighted, we see that the first relevant piece of information is that car 1 has a velocity of 150 kilometers per hour. We also see, if we look a little further in the question, it stays at constant speed, which means that the initial velocity is 150 as well. So the initial and the final velocity of this car is going to be the same. We also know that when there's constant velocity, acceleration is 0, because acceleration requires a change in velocity to be anything but 0. As for car 2, which is the police car, we don't really have much information, except we know that the acceleration is 5.6 meters per second squared. We also know that it starts from rest, which is stated there when it says still, a still police car. So that would mean the initial velocity would be 0 meters per second. That's about all we know there. We can also see that there is another piece of information that we could take from this, because what we're looking for is when the police car overtakes, I'll put a little S there, the speeder. So this is the same thing as saying when they are at the same x distance, because for both of them, x0 is going to be the same for both at 0. You can imagine the cars like this. So this is when they both are at the same place. So I'm not going to draw the car, I'll just draw, okay, two cars, whatever, blah, 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 really badly drawn cars. So two cars, and then there's a parked car, and the other car is here. That's the window. And this is the one that's going, and this is not moving as of yet. And then, well, let's just say the front's there. It's not really important. So I'll just draw now a circle. So the car is going to start, the police car, and the other car is going to be somewhere further down. Let's say over here, and it's still going. And then even further into the story. And this is all x0, 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 x0. And let's just say when they both reach each other at this point, they're both still going forward. But now we have the same x for both. And that is what piece of information we are interested in. So the first diagram is when the speeding car passes the police car. The second diagram is when the police car starts to move. Well, it starts to move at the same time as it passes, but basically this is kind of an intermediary state. And the third is when they both are at the same x point, when that is when the police car overtakes the speeding car. So we know that x, because of this, that x is going to be the same for both. I'll put x1, x2, which is basically the final distance would be the same for both. So if we look at our equations again, the equation that makes the most sense then is x is equal to x0 plus v0t. So A, that would be part A. So x is equal to x0 plus v0t plus 1/2 at squared. Now, if we focus on car 1 first, so all we have is the velocity. We don't know what the time is when the cars reach each other, and we also know the acceleration is 0. So we can simply say x is going to be, and we also know x0 is 0 as well, so we can just say this. Now, for car 2, the police car, right again, x is equal to x0 plus v0t plus 1/2 at squared. Now, there is no initial velocity. There is no x0, so all this is 1/2 at squared. Now, because x is equal for both, we can make x equal to both. So this would be v0t, this would be car 1. Time is going to be the same for both. Let's just say this is the second car. It's not supposed to be squared. Yeah, the second car, t squared. And what we're trying to find here, because we know what A is, we know what V01 is. Let me just plug that in. So V01 is 150 kilometers per hour times t equals 1/2 times 5.6 meters per second squared times t squared. Now, because the units are different here, I have to convert it. So 150 kilometers an hour is going to be, I'm converting it to meters, so kilometers, 1,000 meters, multiplied again by turning hours into seconds. So 1 hour is 60 minutes, or we could just say 3,600 seconds. So if we do that math, we get 41.67 meters per second. So let's put that here. Okay. So that would be, if you move things around, get rid of t, divide by t on both sides. And now we're going to divide, so 41.67 divided by 1/2 of 5.6 would be 2.8. So what do we get there? We get about 14.88 seconds. So that would be the answer of part 1, the time. But now we're looking also for the speed of the car at this instance. So in this, we could use, let's see, I think we could use the first equation. V is equal to V0 plus AT. Because we know what time is, we know what acceleration is, so we can just plug it in. So V is equal to 0 plus 5.6 times 14.88. Now the units are the same, so we're fine. It's 14.88 times 5.6, and we get 83.328. So that is the distance that the car has to go to reach the police car has to go to catch the speeder. So this will be part 1 and part 2. And thanks very much for